Well, we're back, and today it will be a very short one, and it's on the maximum average power transfer. Hopefully you remember we did something like this before the midterm. It was maximum power transfer theorem. Okay, well, in this case it's very similar. Okay, so which is the definition of this theorem is that for you to get the maximum average power transfer, okay, to the load, okay, the load impedance must be equal to the complex conjugate of the Thevenin impedance ZTH. Okay, so what it is that the one that before midterm when we were doing DC, we were saying that to have if you have a circuit that looks like this, you have a load that's connected to a voltage source, right? The voltage source consists of the voltage source, ideal voltage source, and the internal resistance, the series resistance, RL. So to have a maximum power transfer to RL, okay, your value of RL must be equal to your internal resistance of the source, which is RS. Okay. And at that time, I recommend to you that if you have such questions, right, you have to think of Thevenin theorem, because Thevenin theorem reduce your circuit to this form, right, like VTH and RTH. So we would use Thevenin. So this again is the same thing, okay, it's the same thing, but it's just a little bit different is that if you have a circuit, okay, you transform a circuit into Thevenin already, like for example VTH right here, right? But this one, because we have it become impedance already, we don't just deal with R, we have to L and C also the impedance, so we call it ZTH, right? And if you hook, not resistor, an impedance, load impedance, ZL, okay, to have the average maximum power transfer to the load ZL, your ZL must be equal to ZTH conjugate, and the maximum power is equal to the magnitude of VTH square over 8 times RTH. Okay, so let's look at an example, simple example. Let's change colors maybe. Let's see, I don't know if you can see it. Or we can just go to purple again. So if example, have this circuit right here, 0 degrees volt, 4 ohms, 8 ohms, minus 6J ohms, 5J, ZL. So find ZL, okay, to maximize the average power drawn from the circuit. So pretty much find ZL so that you get maximum power transfer and find the maximum power that you will receive. And you use the same concept, right? Since you have to have ZL equal to Z Thevenin conjugate, let's find Z Thevenin. To find Z Thevenin, you short, right? So Z Thevenin equal to what? You short your voltage source. If it's a current source, you open it, right? So 8 ohms minus 6J ohms, 5J ohms, opens here. And what is Z total that you're looking from the open terminal? This is equal to ZTH. So therefore, your ZTH is equal to, well, you will see that this two is in series, and then it's in parallel with the 4 ohms, right? And the whole thing is in series with 5J ohms. And so therefore, it's equal to 4 times 8 minus 6J divided by 4 plus 8 minus 6J plus 5J. So therefore, it's equal to 2.933 plus J 4.467 ohms, or equal to 5.34 angle 56.7 degrees ohms. So this is your ZTH. But you want to have ZTH conjugate, right? Because ZL has to be equal to ZTH conjugate. So therefore, your Z conjugate would be equal to 2.399 minus J 4.467 ohms, or equal to 5.34 angle minus 56.7 degrees ohms. Yep. Now, you want to find the power, okay, the maximum power. You have to find VTH. So to find VTH, the Thevenin voltage, right? So therefore, this is the original problem. .5J, so you remove your ZL out, and this is your open circuit voltage, which is equal to VTH. So looking here, right, currents come out from the source, the positive terminal of the source goes up here, past 4 ohms, right, come to this node, this junction. Well, of course the current cannot go here, right, because this is open. So therefore this is 0 amp, so everything goes down here. So there's no current going through the 5J ohm, so there's no voltage drop, so this is 0 volt. So therefore that means this point is just simply like a wire. So this point is the same as this point, and this point is the same as this point. So therefore VOC or VTH is equal to the V drop across the 8 plus minus 6J ohms, right? So it becomes this portion right here, VTH. Okay. So therefore, you can find the current I here and multiply by 8 minus 6J, or you can use voltage dividers. I would be happy, really happy, if you see this, you go, oh, I can use voltage divider right away. So VTH is equal to ZX, which is 8 minus 6J, divided by Z total, so 4 plus 8 minus 6J, okay, multiplied by 10 volt. So turn out to be 7.454 angle minus 10.3 degrees volt. Okay. So therefore the maximum power, average power, is equal to the magnitude of VTH square over 8 times RTH. So therefore it's equal to 7.454 square over 8 times the real part, the R, the resistive part of your RTH or ZTH, which did I write it down, which is 2.933, right? The real part R. So 2.933 ohms. So the answer is 2.368 watt, the average power right? The unit is watt. So this is how you do it in case you get the question in exam as maximum average power transfer. Okay, so that's it. A short clip on that.